Hi everybody, this is Tor Storley, and I am back with another video. Okay, so in this video, we're going to continue our research into investment analysis using R, Positron, TidyQuant, DuckDB, So this is part 3 of this video series. So what I want to do first is I want to open up Positron because I'm going to be running some code in Positron. So this is what it looks like when I load it up. The session objects, it shouldn't show anything here, so it's starting. Now, one thing you want to probably do, you can clear it out like this in the console. And as you move through these tabs here, because whenever you load data and stuff, it's going to come under variables. Whenever you create charts and stuff, it's going to come under plots. So the console is just like in RStudio, it will print out stuff here. So you can always minimize things, and expand on these things. And to keep a clean environment, that's what you probably want to do. So if you look here now, I do this drop list, and I probably showed you this before. If you're working with Python, you will be using these environments. So you pick whatever have you on your computer, obviously. And you have on and off here. You can recycle here. So right now I don't have Python activated. I have my R session activated. And this is the location, as you can see, for this instance of R that I'm running is R44.2. Okay, so it has a green little arrow here, so it's on. So what I can do then is I created this Quarto document here, but I'm inserting R code, as you can see. There's a couple of ways you can do it. You can do it manually if you like that, by hitting the tilde. No, that's not tilde. It's a backtick, and then a squiggly mark, and R is end squiggly mark, and go down a little bit and do a backtick, backtick, backtick. And now at this point, I can put code in here, R code in this case. If it was Python, you would put Python code in like this. Okay, so right now I have been working on this, so I have accumulated some code, and that's what I'm going to do. So as you can see here, this RM stands for remove objects from specified environments. So when you use this command, if you have anything in memory over here, like variables, what have you, it will just destroy all those. All right, we need to load some libraries because we're going to be doing some analysis. Obviously, we're going to need tidyverse if we're going to use TidyQuant. I had this CoreGram, but I don't think I'm going to be using it, so I'm not going to load it. That's like old school thing. And the same is true with CorePlot. I'm not going to be using these guys. I don't think I'm going to be using this either, so let me comment that out too. But the DuckDB I'm going to be using. The great tables, I'm not sure what the GT stands for. And I also tried out something called GT Extra, although I won't be doing much for this. But I'm planning on in the future maybe look into GT Extras a little bit, because it builds on the top of this GT library that is formatting tables and stuff in R very nicely. And this one is like extras. But I'll show you one example further down here. So let's load these libraries. And when I do, notice in my console how it would script out all this stuff. So I'm clicking it. You can see it loads all this stuff. And notice, because you're using tidyverse and all that stuff, because there's so many packages and sometimes the functions are named the same, it tells you maybe that you could have some issues here. So that's what all these warnings and everything is. All right, so I'm loading the libraries. Then I want to make sure I'm pointing to this location, because that's kind of where I want to work with my database. So I want to set this working directory to that location where my stocks database, DuckDB database sits. And then I'm just going to print it out so you can see what it looks like. So let's clear this out and let's run this and see what it looks like. So as you can see, I'm pointing now by using this get working directory function in R. You can see I'm pointing to that location. All right, very good. Now, I won't be using these commands here, like you see here. Now, these are TidyQuant, which is a wrapper for a few different packages like quant mode, like XTS, like which is built on the top of zoo package, which and also there are a couple of other packages like performance analytics. But I'm not going to load it from Yahoo Finance because in the previous videos, as you might recall, I loaded data from Yahoo Finance and I put it into a DuckDB database. So I'm going to use that technique instead. But if you need to go directly against Yahoo Finance, you can use this technique as you see here. So in other words, create a vector, C parenthesis, of ticker symbols, okay? Then you can either use this magreader pipe function, or if you prefer, you can use the built-in R piping function. It's up to you. Because you're using tidyverse, you will have access to the magreader package. So either one you can use here in this case. Now you use the TidyQuant, and I talked about this before. We get some stock prices from and to. You don't have to specify to if you don't want to. We'll pick up the latest data it can find. And then you pipe it into a group by symbol. So whether it's Apple, Nvidia, Abbott, what have you. Then you want to do some transmute portions. And in this case, here you would do it directly, like you will be selecting the adjusted column and you will calculate, actually you would use this function to calculate the monthly returns, and then wherever you store that data will be called RA. So that's the column rename. And of course you do the same thing here, but for the S&P 500 ticker symbol. All right, so that's just a little bit about this code. So if in case you need to go directly, use this code. Don't use the DuckDB version. Now here I'm creating a connection to a persistent database called StocksDB. And this one sits in that working directory I created above. So I'm creating a variable to hold that connection object, and then I'm passing in the driver to DuckDB, and this is where the stocks database is located. So I can run that now, and it creates, if you look under variables, here you can see the connection data and the driver, etc. So they give you a bunch of information about the connection object under value. So I don't want to see all that, so I'm going to kind of minimize that, and I want to minimize the console too. All right, so now we have a connection to the DuckDB database. Now what I want to do is I want to basically just create a query against DuckDB to list all the tables I have in that database. And here I'm doing some additional stuff. Because I imported the GT package, I can call that by piping it to the GT package. And I can also set a title in that table for the header. And you do it this way by piping it to GT. Then you pipe it to this function called table header or tab header. And then you can actually set the title. And in this case, I'm setting it as a markdown. And I create that markdown text information up here dynamically, as you can see. So I'm creating a bold, and again, I can use HTML. And then I say table in the, and this is dynamically generated from the working directory, as you can see up here. Then I append this to the rest of it to create a title string. And then it's the one I'm passing into this markdown function in GT package. So let's run that and see what it does. So I wrote the connection, and now I'm simply going to create a show table. So these are the tables, as you can see. And notice I get this, and it's in bold and stuff because I forced it to be in bold up here in this text creation, the dynamic text creation. So the one I'm interested in is this. I also created this one in the past, but I'm not going to use it here. I'm going to use this one here and build from there. This one does not have any return data. I'm going to create it as I go. So I'm going to use the built-in function in TidyQuant to build that. All right. Now, we're down here. You can describe this stocks table by using this db get query, passing the connection, and the query select statement. Pass it into a GT table. Again, create the header, and this is all you need to do in order to see that. So as you can see, here is the columns for that table. Here's the type of those columns, integer, varchar, what have you. and whether they're nullable. Of course, the primary key, what I created in the previous video, is not a nullable one because it is the primary key. And now I'm using a sequential ID to get it, and it's called ID_sec. So watch that previous video in case you wonder about some of this stuff. And the same thing was created here. Now, we're not going to be using these in this video, so I'll tone it down on talking too much about that. All right, so we got that. You can also run a summarize function. And here you can see the summarize function. And if you look at the output, it's not pretty because I didn't pass it on to a GT table. But you can see this is basically what it produces. It has the column names with what type they are. They also have unique values here. They have standard deviations here. They have quartile, the first quartile data, what the values were for each column. They have median, and then they have the third quartile, and then they have the count of number of records in this table. And as you can see, there's 1,352 records in that table. So it's fairly large. It's not huge, but it's, you know, it has a lot of data for stocks because it has stock data for every stock in the S&P 500, because that's what I did in the previous video, extracting the values from those. So check those out. Check the previous videos out in this series to figure out, you know, how I came up with all that data. Excellent. Now, next thing would be, this is where I'm going to actually start doing some stuff that's going to relate to what we want to do. I'm going to select these fields, symbol, date, and adjusted close from the stocks table in DuckDB, where the symbol is one of these. So NVIDIA, Apple, Abbott Laboratories, and the S&P 500 index data. And then I want to order by symbol and then by date. So when I run this, it creates, as you can see, this is just a console, so it just prints it out. But if you look under variables now, you can see it created this stocks. I don't know if it's a table or what it is, but this is what it looks like. So it has a symbol, a date, and adjusted close. And if you remember from previous videos, you remember how you can read this kind of stuff. It will tell you the min, the median, the max for each column like this. So it gives you a lot of information about the distribution, for example. The adjusted close, you can see the max is huge. So this is very misleading the way I show this right now, because in this symbol I have 500, and one of them is the S&P 500 itself. So let's see if that's actually the case. So if the symbol is equal to GSPC, yeah, of course, because these are index numbers, so the adjusted close will be in the thousands. You see that? But the others, if I say AAPL for Apple, okay? Notice these prices are a lot more reasonable. So the reason it showed this adjusted close, the max, is because of now that I filtered, you can see this is the max price for Apple is $259, and the min was $15. So over time, Apple stock has grown dramatically. Anyways, I just wanted to show you that. So be careful watching these. You got to filter it in order to get the right numbers. Okay, so that's the stocks data. Now we got a bunch of records in there, 11,068 records. The next thing I want to do then is I want to filter the data. I only want a few stocks. So in R, I create this vector, and I want to create it based on Abbott, Apple, NVIDIA, and the S&P 500. And then I create a variable to hold the result of all this piping, passing in this stocks data frame here, or dibble, whatever it is. And then I'm filtering it based on symbols that are in this vector. So symbols, parenthesis, in parentheses, symbols. You see that? Whatever that smaller amount of data is, I'm piping, continuing into the next one. I want to group it by symbol. So when I do the next parts, it will be by that each grouping. So if I filter out Abbott here, this piece will only apply to Abbott, and then the next one will be Apple. This piece will only apply to Apple. because what you're doing is you're calculating return data, because I want to see what the rate of return is. And what I'm doing is I want monthly returns. I want to call the new column where I'm putting the returns to return, and I'm using adjusted close to calculate it based on that. But because I want to show you the GT extras output, I'm multiplying the return by 100. And the reason I'm doing that is because otherwise you just see zeros in the output, and you're not going to understand that at all. So let me run that. Okay, so I did all that, and you can see it spools out all the printout statements here. So this next one here is, for me to get in the right format, I need to organize the columns, because I want all the ticker symbols to be in a row format. And then I want the output formulas basically to be in a column format. So what I'm doing is I'm using this pivot wider function. So I'm piping in this SP500 selected from up here. And then I'm pivoting wider the names from the symbol columns. They're going to turn into rows now. And the values are going to come from the returns column. So let's run that. And now I created this pivot wide. Now, if you want to see the data, just collapse this console and expand on this variable column. Go to the wide and click on this little icon here. Notice the returns I have multiplied by 100. So you can see this is 2%. 5.75%, negative 9.5%, and so on. So here I pivoted this stuff and basically have the dates where they are kind of where these are matching. Okay, so now I can simply pipe that result set from that SP500 wide. Here I'm selecting every column, but I don't want the date column. So I'm putting a negative here in front of it because I only want to see the other columns, not the date column. So it's a quick way of getting rid of. Instead of listing the other 4, I can only get rid of this 1 by doing a minus. Then I'm piping it into this function here, which is in the GT extra. And it's called GT underscore PLT underscore summary. And I want to have a title in my output. So I'm going to call it summary statistics. So notice what happens now when I run this. Notice how cool this is. With these 3 lines of code here, it produces this beautiful plot. Notice this. Here is the Apple, Abbott, the S&P 500, and NVIDIA. And notice it gives you a history plot, and it also gives you the central where it crosses the 0 axis, and it gives you the min, the max, etc. So this is pretty cool, as you can see here. 2.8 was the median, standard deviation, the mean, and then max min from each one. And so this is really nice and beautiful. You can see 132 rows, 4 columns. So that's how you can use the GT extra in a super simple way. Obviously, if you want more information, you should simply do a search for example, if I highlight this and hit F1 now, it will tell me, because I have the GT extra installed, you can see it gives you information here about that function I'm just used now. And it tells you, even you can see it here, what the output can look like and what each one. So it's looking for a data frame or a table object in order to do something. All right, so that's a little bit about how you can pretty up your output a little bit. Now, I tend not to use, I'm not that familiar with this one yet, so I'm not going to be using that. But I will be using the GT just to get some tables and so forth. Okay, very well. So now we get the plot of that. Now what I want to do, I want to create some table objects for the monthly return. So these stocks I got. So here I'm selecting everything, but not the market data, not the S&P 500. And I want to compute the rate of return, and I want to call that column RA, and it's going to be a monthly rate of return based on the adjusted close price. So I can run that. Now I'm doing the same thing here. Notice the difference. This is not GSPC, which is not the S&P 500. This is the S&P 500. And in the TidyQuant model, the RA represents the stocks that you want to compare against the market benchmark, which is the RB. So RA is the stocks you're comparing to the market index of RB. So I use the S&P 500 as a market index. So I want to set that RB equal to this. So when I run this, you can see over here, I can get rid of this stuff. And hold on a second. Let me get rid of it and then collapse it. But if you look under variables now, you can see you have RA, which is simply symbol, date, and RA is the rate of return for each one of these dates for each stock. So APL, Abbott, and so forth continues down this. The RB is only the GSP. So what I want to do next then is, since I already got the data now in the same format for RB and RA, I want to join them together. So I'm running that command here, and I'm calling it RA-RB by using a left join between RA and RB by using the date column to kind of figure out where each row should go. Then what I do here, I simply, because the output, if you look at the output here, you can see that that output is not in a clean format. So RA-RB, you can see it's called symbol.x, has a date, has RA, and then there's a symbol Y here on RB. I don't want that. I want to get rid of this symbol Y for one thing. I want to rename this one to symbol only. And the way you can do that is by simply doing this way. Pass in the RA-RB, call it RA-RB, so you're just basically going to update this particular variable. Use the rename function. Now, you shouldn't have to do this dplyr in front of it, but I just put it here. You should be able to just use the rename. So you say symbol.x should be renamed to just symbol. Then pass that on and select only these columns from the output. So when you run that, now when you look at the output from that, so let's get rid of that and let's collapse the console. So if you look at RA-RB now, there's 4 columns. And notice now you get symbol, date, RA, and RB. This will be against the S&P 500. So for each one of these symbols, Apple for this date is going to be against this date for the S&P 500. So this one will be reoccurring every time based on these dates for every stock. So this will be repeating by grouping, basically, if you want. All right, so very good. Now we can create some more objects here, calling it GSPC, and the RB we're going to use just to get the market data, because that's what we created up here, the RB in this section here. This section here. So we're referring to this guy because that's the market data. And then for the others, we refer to the actual RA-RB data frame or table or whatever it was. And here I'm filtering by each individual, and then I ungroup them. I mutate it by setting the name of whatever this column is equal to RA. All right, so I'm going to create an object called this, and each one of them is going to have this as a header. And then I'm going to select the date and this. So when I run this whole thing now, it's going to do for each stock in my series. So let me pull out here. There's a lot of written out stuff. Let's collapse that. Now you can see the variables here. So if I look at APT, you can see that's 132 rows and 2 columns. And date, and then of course the name of that particular one is on the top here. But these are the return data for that particular data frame or table object. So that's what we did here. All right, now what next thing we want to do is we want to create an XTS object for each of these stock tables. So one for market, S&P 500, one for Apple, one for Abbott, and one for NVIDIA. And I just call them _XTS. And the way you do that, you use this function, XTS. And why do you want to use that? Well, for time series, this is a pretty good one, and it works well with the performance analytics package. So here I'm simply, from this GSPC, I'm simply selecting this GSPC column. That's all that does. So that's what this piece is doing here, okay? And then I do the same thing for Apple, Abbott, and so forth. So let's run that. And we order by the date, obviously, for each one. And now what I can do is I can do the same thing for these RA and RB objects. And the reason I'm doing this is because I don't know what I'm going to be using later. So I create an object for each kind, okay? So this is for RA and RB. Then now I can actually start looking at things. I can pass in the S&P 500 XTS object I just created above, this stuff up here, and where I converted it here. Now I can call that because it works nicely with QuantMod and so forth. In this particular chart series here, I can pass in my object. Now I'm not using TidyQuant here. I'm going directly against QuantMod. And these are the different inputs you can have. In case you wonder what all this means, hit F1 on the chart series and it will open up QuantMod. And as you can see here, this is the chart series of QuantMod, and all these are the input values you can use. And if you look further down, they will tell you what each one is. X is this, type is this, subset, and so forth. So what I'm doing here is I'm basically creating a basic chart. So when I run this, I give it a name, S&P index price chart. So it's going to use the index numbers. Major ticks is auto. It doesn't have any minor ticks. So what I want to do now is I want to clean this out, and then I want to run this code. So let's see what it looks like. And as you can see, let me minimize the console. Let me minimize the variables. This is the pricing chart for the S&P 500. Now, these are based on the returns, obviously, as you can see here. It fluctuates between like a negative, I don't know, 15 maybe, or not even that, and a positive. So that is basically an index. I shouldn't say price, I should say return, because these are return data. We're using returns here, we're not using the prices. Now, if you want the prices, you will have to create a data frame or table object that holds the prices and then plot that. But that's not what, so don't look at the word price, okay? That's misleading here. Let's look at what Apple will look like. Notice what Positron does. It actually creates a second chart, but it keeps the first one so that you can toggle between them. So this one has what is called a Bollinger Band. You see this? Add Bollinger Band. This N20 means 20 periods. So if these are monthly data, you want to create a moving average over the 20 months. And you use the simple moving average function here. So that's what this is doing. So this is a different, because I added this to it, right? So notice I put a Bollinger Band on it. Now I will talk more about the definition of all this output and what it means and so in a later video. But for now, just this is a Bollinger Band, which is typically calculating 2 standard deviations around the central values of this chart. Okay, we'll get back to this in more detail. Here what I'm doing is I'm using the subset function, and I'm saying, hey, only plot the data between August 2014 and February 2016. So when I run this, you can see I'm adding the Bollinger Band here too, same thing. But notice the time frame down here on the chart has been subsetted. So it's less amount of data you're showing in your plot. And finally then, I want to show you, because this is an XTS object, right? You can also use this technique in XTS, where you can you just put the XTS object, put a square bracket, and then you can say, hey, year-month / year-month. So what that means is I want to only see the data from August 8th, 2016 through the May of 2020. So that's what this is doing. So when I plot that, as you can see, same thing with the Bollinger Bands. But notice, August 2016, May 2020. So that's another way you can subset or reduce the amount of data that you want to plot. You basically take an amount of data from that set. Very good. Okay, so now what I want to do is I want to merge these different XTS objects into this combined XTS. And why do I want to do that? Well, because I'm going to use some other types of charts. So let me run that. And if you look now, let's get rid of all this console because it keeps printing out. Let's look at the variables. So if you move this down a little bit, you look at this combined XTS, this is what it will look like. So you can see you have Abbott XTS and, the S&P 500, Apple, and NVIDIA XTS with return information. So that's what the combined one looks like. Now, I used the merge function to build a table of these XTS objects, so these become columns. You use the merge function for that. If you had rows, you would use maybe rbind, and cbind if it was columns. They work slightly different. So here I'm going to create a data frame based on this particular XTS combined function. So you can do that this way. The core data is a zoo object. Zoo is the underlying object for the XTS package. And you can use this core data to actually drill in and get the underlying columns and data points in via the zoo package. So the core data, as you can see, is like this. You can read up on this by hovering over it, or just do a help on core data in the zoo package. All right, so what I can do now is I can simply use this chart correlation. In case you wonder, just hit F1 on your Windows machine, or do a question mark and then chart correlation and see where you end up. So here you can see it creates a correlation matrix chart, and this is created by Peter Carl, as you can see, and these are the arguments that it's expecting. So it's going to build like a histogram. So this one liner of code is going to build a histogram. So let's see what that will look like. So let me clear this out. Let me minimize everything. And then let me run it and see what it will look like. Okay, so I'm going to run it here. And it produces this plot. So one line of code passing in this XTS combined object will look like this. Now, I don't have a lot of real estate, and I work in Positron here. One thing I miss from that is an R is that you can expand on this, but it's kind of hard to do here because usually we can zoom, and then this one becomes a floating dialogue. But I suspect that has something to do with that it keeps track of all these plots, so it keeps them in the margin so you can drill between them and so forth. But here you can see it produces a histogram. It gives you correlation value against each of these different stocks. Now, from this one, it doesn't tell me much at all. It tells me here that Abbott versus, I'm not sure. Is it against the GPC? It must be, because here's Abbott, here is the S&P 500. So the correlation must be 0.64, right? And here is Apple versus the S&P 500 is 0.68. Now, I don't see GSP versus itself. So it has some mixed plots here, but it's kind of getting a little dated, I think, that this kind of look and feel. It's really hard to understand it unless you really know what these plots looks like in real life. Now, another thing I can do is, and I had really a lot of problems with this in Positron, not so much in R, but in Positron, to set this, the print output stuff, and how many rows and columns you want to see. Now, this one may or may not work. Let me see. I'm going to try it, and I get an error, right? So let me try a 2x2 plot and run it again. And now it's doing something, but it only shows 3 of them. Do you see that? So I don't feel this is stable yet because it doesn't produce all 4 of them. So what happens if I set this to 3 rows and then 2 columns and try it again? See, now I'm getting 4. So it's really weird. And yeah, so you can see I'm getting QQ plots, which kind of gives you the distribution against this normal distribution. So the way you look at this stuff is that these dots out here, if they start going down and way up, then most likely you have a student T distribution of sorts with fat tails, and they're not really normally distributed. Now, they don't look too bad, but it's really hard to tell because the size is pretty small. So it's really hard to read this chart right now. But I want to show you can use this QQ plot in, and I assume this is probably, no, this is from the performance analytics package, as you can see down here. So, okay, so you can use chart QQ plot, and then you're passing in your combined XTS object. Then you pick the first column, the second column. So each one of these is its own. Abbott, GSP is 2, or yeah, 2, I think. And then 3 will be the Apple, and 4 will be the NVIDIA. So that's how you can do that plot. Now here I can also do a box plot. So as you look here, for whatever reason, it didn't like that. Let me try it again. Sometimes it gives you this because it doesn't have enough real estate to do it. but I don't think this works sometimes, but it's kind of strange. Okay, so I can't get this box plot, which is kind of irritating because I wish I could. All right, so let me, but again, it's in beta, so I don't know if it's something internal here or it's never going to do it. I don't know. Here I'm running a CapM. So if you look here, this one was printed out using this transform function, which is basically just T parenthesis and then the object here. So if you don't do this T, all these guys will be column names, okay? So you have one row with all of these as column headers and then the number following. But because I use this transform or transpose, as you call it, function, I'm getting all of these column names unpivoted into a row name and then the values, as you can see. Now, I probably will try to make a video where I kind of tell you a little bit more what all this stuff means. Okay, but it won't be in this video because I'm just showing you how you can actually create TidyQuant output here and maybe some quant mod output if it kind of is easier to do. So here I'm creating another variable, doing a select statement, but I'm selecting from this stuff, but I only want to see a few of them. I don't want to see everything. And then I'm going to pass it into this GT object, and I want to give it a title of this in bold. So let's run that and see what that looks like. So as you can see, it's pretty basic. CapM metrics for Apple. You have an alpha, you have a beta, you have a bull beta, as it's called, where you only regress the positive percentage returns, and anything that is negative is set to 0. This is the opposite. This is called a bear beta, and you set all the positive returns to a 0 and you keep all the negatives. So you have bull markets and bear markets to calculate the beta. In any event, we can talk some more about that later. Okay, the next thing I want to show you is I can also create a correlation table, as you can see here. And again, I captured in this variable, and then I'm passing it to the GT table. And it looks like this. Again, there's probably not so much to say about it. We already saw similar things. But I'm showing you a different way you can do it. So let me get rid of that. Here, you can simply transform it into a table in R by using this function. So not the fancy GT table, but simply look like this. So if you know what you're doing, this might be quicker and cleaner and easier, but it's a preference thing. And here you got the RARB. You're going to filter by this one particular stock for Abbott Laboratories. You're going to use the RA value for Abbott, for all the returns. I'm not going to pass in the market return, and you do that by setting it equal to null, the RB, or the one you're comparing it to, the benchmark, if you will. And then this is the performance analytics function I'm going to be using. Table annualized returns. I'm going to annualize the returns. Since my data is monthly, I'm using a scale of 12. If it was daily, it would be probably based on trading days of 252 trading days in a year. If it was a quarterly one, it would be 4, the scale. And if it's yearly, it would just be 1. I'm not going to have any risk-free rate in this case. I'm just setting it to 0. Pass it to the GT table and give it a title. And let's run that. And this is what it looks like. So now we got the annualized return for Abbott, which is 12%, 12.49%. The Sharpe ratio is 0.63, and the standard deviation is almost 20%. However, we can talk some more about these output values in a separate video. So let's see here. I'm getting close to the end, I hope. It's running late. There's 40 minutes already. Here I'm doing the RARB from earlier table. Filter by Abbott. I'm using, again, the same thing, but in this case, I want to create a statistics table, as you can see. So let's see what that will look like. Okay, again, notice all the headers here, right? That's not really what I like to see, but because I'm using the GT table, it's very hard to fix this unless you create a data frame of sorts. So if you want to just do this, you could give a variable is equal to the whole thing here, and then you'll simply do the transpose function again. All right, so here I'm going to show the summarized statistics for NVIDIA, and I will show it in a console. So if you look here, Here is NVIDIA, and here is the summarized information about it. So this is for the date in that particular, and we also had the S&P 500 here. Very good. So now I want to do a performance chart for Abbott Laboratories. So what I can run it like this, and let's, yeah. So this is another one from Performance Analytics that gives you a cumulative return. So as you can see here, it keeps creeping up over time. So it's been pretty much upwards, upwards, upwards all the time here. And then you have some other types of things. You have monthly returns. So you can basically see how they spike around the 0 line here. So you can get an idea. And then you have drawdown, which is another metric in the performance analytics. Next, we got the relative performance. And again, this relative performance, you should really not look at the numbers on the y-axis here. What's more important is to see the direction. So Abbott versus S&P 500, well, from whatever that is, mid-2015 down through January 2017, Abbott was doing worse than the S&P 500. Here is doing better than the S&P 500. So it's more important to look at the direction of the lines here than try to interpret these numbers. Here's another one of those. This one is for Apple. Whoa, look at that. Apple has been pretty positive all along from 2014 on against the S&P. So Apple must have done pretty good. And if you look at NVIDIA, that one is really going totally to Pluto. Look at this. From here, about, I don't know, when is that? Mid-2022 or a little closer to 2023, I would say. September, October, November timeframe, and up through today or December of 2024. Look how much it's been climbing. So that has done really well, and that's probably because of all the AI information it had. So that's a little bit about the charts and stuff in the TidyQuant and how you can manipulate data using DuckDB, TidyQuant, QuantMod, and some R functionality here. And I hope you like this video, and if you do, please give me a like and consider subscribing to my channel. That'd be great.